Welcome to CSX Week 3. This is Infrastructure Week, and we have a lot of great things planned. We'll start the morning with a talk by our general partner, Ali Yahya, and Sreeram Kannan, the founder of EigenLayer. Please join me in welcoming Ali and Sreeram.
Sreeram, thank you so much for joining us today.
Thank you so much, Ali. My pleasure.
It's great to talk about what you're up to and also about your journey and how you've gotten to this point in kind of the arc of your career as a founder. But let's start maybe just with a big picture about EigenLayer. What is your latest framing for the problem that EigenLayer solves?
EigenLayer. What is EigenLayer? Eigen in German for your own layer. Anybody can build whatever they want. The core thesis of EigenLayer is open innovation. So what is open innovation? So if you think about decentralized networks like Bitcoin, you can think of these networks as made of many different layers. So there's a layer of security, for example, in Bitcoin, proof of work, layer of security. Then there's a layer of consensus. We all agree on something, that what's the next block. And then there's a layer of execution. For example, in Bitcoin, it's Bitcoin script. And on top of it is the application. In Bitcoin, it's like send and receive Bitcoins. So all these four layers are bundled together in the Bitcoin blockchain. So I think of, nowadays people talk about app chains, right? Bitcoin is the first app chain. It's integrated all the way up. And this is typically how any industry starts. You have like a fully integrated system because specialization is not possible when you're inventing something off the bat. And what Ethereum did is expand or modularize the system so that anybody can build applications. So the application layer becomes modularized, so anybody can build applications and deploy them. And what does this do? It's a really interesting phenomenon I call the separation of trust and innovation. So the blockchain is supplying trust, and anybody can now supply innovation. Like I can write a piece of code and then deploy it on top of the Ethereum blockchain. And you don't need to know who I am, where I'm from, or anything. You can just trust that that system works as expected because Ethereum's underwriting trust into it. So this is a huge deal. And, one of the stories I like to say is, one of our teammates now, Gajesh, he was a 13-year-old kid in India from a random place. He wrote this DeFi program for, trading. And, without blockchains, there's no chance anybody would trust this kid and put like a penny into it. But there's $7 million that was locked into his contract, and people are trading because they don't need to know who Gajesh is or where he came from or what his antecedents are. The trust is underwritten by the blockchain. This is awesome. So opens up so much permissionless innovation. That's why we have the whole pseudonymous economy. Like the idea that I can be a nobody and still build systems that are highly trusted that only JP Morgan could build in yesteryears. But that is not, in our view, enough open innovation, because what's happening is anybody can build applications that can fit on top of the Ethereum structure, which is the security model, the consensus model, the execution model, the EVM, and then build on top. Ethereum itself took one more step further to do the roll-up centric era, where it said anybody can now build new execution environments that can go on top of this common security. And so now like a rollup is basically an execution environment you build that you prove to the Ethereum blockchain that you're running correctly. But now people can build different kinds of execution environments, not just Solidity and EVM, but you can build Mo, you can build all kinds of other things, WebAssembly and Rust and everything else. But even that has a consensus bottleneck, because the way nodes come into consensus and then create your final solutions are all determined by the Ethereum blockchain. So you have the consensus layer is shared. EigenLayer is designed so that it's just raw decentralized trust. You have a group of nodes which stake, and these nodes stake, and then you create an arbitrary service. And for this, let's say the service is, I want to get consensus on AI inference. So these nodes run this AI inference software and then arrive at whatever consensus protocol you write, and then give you the outputs. So I think of this as the progressive deepening of the amount of permissionless innovation that's available. So from Bitcoin, where anybody can participate in the network, but nobody can program it, to Ethereum, where anybody can write smart contracts, to the roll-up centric era, where anybody can write execution environments, to EigenLayer, where you can write any crypto service you want on top of a common decentralized trust network.
That's a beautiful way to explain it. Well, and to summarize it, so like Bitcoin is this vertically integrated blockchain that's almost entirely application specific. It has one purpose, and that is to serve as a kind of store of value. It originally intended to be a blockchain for payments. In the end, it ended up being more like a kind of digital gold, and that is the one thing that it does very well. Ethereum modularized a little bit further by decoupling sort of the security aspect from the application. So it introduced a programming language. Now you can write all sorts of different kinds of applications as long as you conform to the one specific virtual machine and execution, like the runtime that Ethereum puts forward. Like it has to be EVM, and that's kind of the set of constraints that you have to operate under. And you also just have to take the consensus implementation that Ethereum provides. And so EigenLayer goes even further and decouples like the security aspect, the security that the validators provide to the network from consensus, such that you can now build your own consensus layer and therefore also build your own execution environment, have your own virtual machine, which really kind of unlocks the design space and makes it much broader. For certain things that maybe don't fit into the EVM, you can now sort of build something that would normally would require you to build an entire layer one blockchain from scratch. Now you can kind of more easily tap into the security that Ethereum might offer and build it in a way that's much easier using EigenLayer. Is that like a good? That's a
great summary of what we're trying to do. So services built on top of EigenLayer, we call them AVS, actively validated services, and it's chosen carefully. Like it's a service that is built on top of a decentralized trust network, and the mental model that we want to create is not like, hey, whenever you want to build a new thing, you have to build a chain. A chain is basically an ordered ledger which has some kind of execution attached to it. But a service could be like a co-processor. You're sitting on a blockchain and then you make a call and then it returns you an answer. Yeah. It could run it based on computation. It could run it based on storing data. It could run a service based on fetching data from the internet, all kinds of things. But an actively validated service, it could be a chain, but it doesn't have to be a chain. It's just a service that provides something narrow. And one analogy is to in Web 2 and cloud, you have the idea of software as a service. Right? Mm-hmm. So you build a service, you say, hey, here's a piece of code. I throw it on top of AWS, and it's running this code. And anybody who wants to use it just subscribe to this fee model and then use this particular service. And when you're building an application today on cloud, you just go and usually concatenate a bunch of software as a service solutions, and then only write the things that are not available for your particular application. So you don't have to write your own database, you don't have to write your own login, you don't have to write your own payment solution. You use Stripe, you use MongoDB, you use OAuth, and then you put them together to build whatever applications you want. That's how we got so much open innovation in the web world. Anybody could now spin out a website, like Shopify makes it easy for you to run your own e-commerce store. All this kind of stuff. We want to bring the same amount of permissionless innovation to crypto.
Yeah. Another metaphor, which I'm curious if you would agree with this way of framing what EigenLayer is. Just sort of historically in the world of computing, there was this whole trend of virtualization, where you had like a virtual layer that allowed developers to essentially write code that was decoupled from the hardware, the actual sort of physical bare metal on which those applications would run. And that layer of virtualization would allow for much more portability of code. It allowed for more flexibility. You didn't have to know as much about the hardware on which your application would ultimately run. And then maybe here in the world of blockchains, if blockchains are computers, kind of the specific consensus implementation plus its runtime is kind of like the bare metal. Mm-hmm. And maybe EigenLayer, by kind of decoupling that from the underlying security that a blockchain provides, is kind of like a virtualization layer, where now as a developer, you can kind of develop an application without having to know or having to care as much about the specific implementation of the underlying consensus. And you have so much more flexibility of the kind of underlying quote unquote hardware to pick from. And so maybe kind of EigenLayer is like the natural next step, in the same way that in traditional computing, we went from like targeting very specific physical hardware to eventually moving to a much more virtualized environment, to the point at which you then have containers. Maybe AVSs are somewhat analogous to containers, and the way that containers can interact with one another may be similar to the way that AVSs can be composed with one another as well. And it's dangerous to think by analogy, but I think it maybe is a useful framework just to understand like the implications and the significance of something like EigenLayer. But I'm curious, do you agree with this?
I think it's a great analogy. Somewhat different, but related analogy we use is EigenLayer as verifiable cloud. right?
Yeah.
So you have the cloud, and you write an application, and then you deploy it. And usually cloud is made by virtualization. Right? So the idea is like you have an arbitrary piece of code, and then earlier you have to build your own server to actually run it. And then the cloud said, hey, I'm going to abstract all of that out. You just run a piece of code, throw it on top of the cloud, and then let it run there. It's a cloud for decentralized services, which are verifiable. So you write a service, and then you say, hey, end nodes need to put up so much stake. They need to come to consensus in this way, all of the conditions, and then just throw it on top of EigenLayer, and then you have this running service. So the other thing, Ali talked about containers and composability, right? So one of the things that we do want to do here is one of the counter patterns we observed in blockchain is because every new breakthrough needed building its own blockchain, they all fragmented the ecosystem. And to build a layer one blockchain, you need to do so many things well. You need to get your wallets well, you need to make it real money, you need to get a community and all of these things, as opposed to specializing, right? Like SaaS worked very well. In fact, turned out to be one of the most profitable sectors to invest because it's hyper specialized. Build something which is really, really focused on what you're really good at. It's much easier to figure out who will build the best distributed database than who's going to build the next social network. And so that's exactly what EigenLayer allows us to do is everybody specialize and build super specialized services, and these services can now compose and work together on a common settlement layer, which is a good.
Makes 100% sense. And we'll come back to a lot of the technical details and some of the implications of what you're building, and then also to the broader kind of the sort of trends in the space. But I wanted to touch on your sort of journey and how you came to want to solve this set of problems, and then also your history as a professor, and then kind of your journey from being in academia to becoming a startup founder. So what was that story? What's the genesis story for EigenLayer?
Before starting EigenLayer, I was a professor at the University of Washington, Seattle, where I ran the UW Blockchain Research Lab. Before that, I used to work on computational genomics. So maybe I can start from why that happened. And my PhD itself was in actually peer-to-peer wireless networks. I got into my PhD, doing research out of curiosity, right? So you work on things that draw your interest and attention rather than out of a specific goal for impact, right? It's like you're wandering and you find something interesting and you go dig through what that is. And that's how I got into the space of network information theory, which is what I did my PhD in. And at the end of my PhD, we solved some long-standing open problems in that space. And I was expecting something to happen, but I didn't even know what I was expecting. It's like, oh my God, we solved this major problem in network information theory, and it's going to be something. Then I look around, and other than the 20 people who are working on that subfield, nobody gives a damn. And it was a little bit disappointing. You spend 6 years trying to solve a problem, and you solve it, which in my view, I shouldn't have been able to solve, but I did it, and I'm like, okay, this is going to be amazing. And it turns out nobody cares. Then I sit around, I'm sitting and trying to root cause this problem, and then I find out that if you did not optimize for impact, you optimize for curiosity and doing something which has beauty and depth and so on, rather than something that has impact, you should not expect impact as a kind of a random outcome because you're not thoughtful about it. So I drew this two axes, x-axis is technical depth, and y-axis is impact. Then I was working on problems which had a lot of technical depth, but not necessarily high impact. So I said, okay, let me just try to figure out what this other axis is, impact. And I was looking around, and I went to a talk on genomics by one of the founders of the Human Genome Project, Craig Venter. And I'm like, wow, crazy stuff going on. This is 2012, crazy stuff going on here. Guys inventing new species, talking about why should robots be mechanical? We should just make biological robots to do whatever we want, all kinds of crazy stuff. And I'm like, why are we trying to get 10x download speeds here? Let's go and figure this thing out. So I switched all over to computational genomics, which is what I did my postdoc at Berkeley and Stanford. And I was working on DNA sequencing. And after I finished my postdoc, I was looking for faculty positions. And one of the places I interviewed was at Caltech. And at Caltech, they asked me this question. Hey, you're working on this DNA sequencing algorithms. What if somebody invented a new machine that just solves this problem end to end? What would you do? And then I'm like, oh, if somebody invents a new machine that just solves this problem end to end, what would I do? Said hey, I didn't know about DNA sequencing 2 years back. I figured this thing out. I'll figure something else out. And they said, okay, let me ask you this question in a different way. Suppose I give you infinite amount of resources, infinite amount of talent, the best people you want in the world.
This is possibly part of your interview.
This is part of my interview at Caltech.
A great interview.
Yeah, this was one of the best lessons I got in my life. And suppose I give you like infinite amount of resources, infinite talent, and you got 30 years. So you just go shut yourself like a hermit in your lab, and after 30 years, you have to come and tell me what you invented. What would you do? I was so baffled by the scale of this question because it requires the degree of unconstrained thinking that I was not used to, because we're always in our own, I have X, I can only do X plus delta. Like that's our nominal way of thinking. This question was
and unconstrained in every sense. It's like resources, time, talent.
Everything. And then, what are you going to do? And I was baffled, and I'm like, okay, I didn't get the job, like, no wonder. And I did get a job at the University of Washington, which I'm thankful for, where I started working on genomics. We had all kinds of awesome collaborators. But within like some time, I was like, I need to have a 30-year project. Otherwise, I'm not working something. So I formulated my first 30-year project as something in genomics, basically decode how information is stored in living systems. So that was my 30-year project. I had like great collaborators. I was working on it until 2017, 2018, when I got into blockchains. And so that was like a big deal because I had a 30-year project and I had great collaborators, including some Nobel Prize winners, some like breakthrough prize winners, all kinds of really good people. And my advisor calls me from my PhD and says, hey, Sreeram, there's this thing called blockchain, Bitcoin has throughput and latency problems. This is what you used to work on your PhD.
Was this David say?
Pramod Vishnu.
Pramod, yeah.
Who's the professor now at Princeton here. I'm like, okay, yeah, I'm trying to figure out how information is stored in living systems. Why would I work on some random speculative BS? Took me several months. It was a very good fit technically for what we knew, but it was so off from my long-term view of what I should be working on for 30 years. Randomly, one of the days I was rereading Sapiens from Yuval Harari. And he makes this thesis that humans are special because we cooperate flexibly in large numbers. And so I take this to mean essentially that we are special not because we innovate, not because we are intelligent, but because we coordinate. And the usual friction to coordination is trust. So if we can solve the trust problems, it's kind of like a significant upgrade to humanity. So that was my thesis for getting into crypto. Just like the internet is our communication superhighway, crypto is our coordination superhighway. So I got into crypto based on this 30-year thesis. To even now, like EigenLabs, our vision is not to build restaking or verifiable cloud or anything. It's to build humanity's coordination engine.
Yeah,
that's our goal. And so we backtracked from like this crazy 30-year unconstrained problem to what we can actually build today.
I love this because in an environment that is saturated with meme coins, often, especially on Twitter, this is like just a good reminder of what crypto is actually for. It's a technology for enabling greater scale cooperation. That is truly the most impactful sort of thesis behind what crypto is and what it's about. One question: did the ideas from your PhD and then from your work in genomics influence kind of the ideas behind EigenLayer, or do you see them as completely distinct?
Definitely the set of tools that I learned from my PhD. I worked on this field called network information theory, which is, information theory is about quantifying the fundamental limits of information propagation, information communication, inference, all of this stuff. And network information theory is when you have a network of nodes, what are the limits of like information propagation there? And I would say absolutely like the set of work we did on blockchains is built on that. Less so from genomics, but what happens when you kind of like move fields like 3-4 times in your life is you pick up a set of like meta heuristics, which are really, really, really important. For example, one of the things I learned from genomics is I used to work on DNA sequencing, and this question that I was asked at this Caltech interview, which was that, hey, what happens if somebody invents some new technology? One of the heuristics I picked up from there is you never work on a problem for a time scale larger than it's stable for, right? So
then the problem is stable?
Then the problem is stable for. Like if some technology is changing every 2 years, trying to work on a theoretical model that'll last 30 years is actually like a bad bet. So you want to make sure that the time scale of your problem formulation and the stability of that particular problem needs to be matched. And I find lots of places where academics work on problems which are extraordinarily mismatched. So these kinds of meta heuristics inform taste in how you figure out what sets of things to work on. But most directly, it was tools from network information theory that actually played a role. For example, this question, suppose you have n nodes in a distributed network and you want to arrive at consensus, and each of them have some bandwidth, C. What is the maximum rate at which you can arrive at consensus with a very high degree of security? And if you look at all blockchains today, they're all built on full replication. Right? Like even Solana, which is the fastest blockchain today, is built on full replication. Every node downloads and receives all the data. And so if each node's bandwidth is C, the system can never run at more than C. Whereas the theoretical limits we inferred was actually if there are n nodes, each of them have bandwidth C, you should be able to run the system at bandwidth n times C. That's like an insane thing. And especially in Ethereum, for example, n is the number of validators, is 1 million. So you can actually scale these systems 1 million x. I'm like, wow. I used to work on wireless, right? I mentioned before. And wireless, if you could scale a system 5%, you'll be the king of 5G. Right? If you just make wireless better 5%, you'll be the king of 5G. Here you have a system you can improve like 1 million x. Nobody seemed to be doing it. I'm like, this can't be true. We should do it. So that's an example of what kinds of fundamental principle or first principle thinking that you learn and you apply it, and actually you can find and build systems that actually do that.
So in some ways, even though you weren't thinking along the lines of impact when you were doing your PhD, maybe indirectly, like some of these ideas made their way into what you're doing now, and will have great impact.
Yeah, thank you for saying that. Hopefully it will have great impact. We're just getting started here. The thing that does compound is knowledge always compounds, right? Especially if you build heuristics that build on top of each other. You have a lattice work of mental models that you're successively refining over time. So absolutely, you find that you can use what you know.
Well, maybe outside of the sort of intellectual questions or the intellectual lessons from your time in academia, are there any lessons or anti-lessons that you learned from that time for being a startup founder and running an organization, hiring people, building a product, running an engineering team, et cetera?
Absolutely. So one of the things I used to notice among academics, especially those who work on theoretical and abstract stuff, is I noticed this pattern, which was a little bit weird, which is that over time, a large fraction of them kind of become bitter. And I used to see this, and I'm like, why is this happening? It's a bizarre thing. And then I used to, on probing and trying to find out what is going on here.
And you mean throughout the arc of an academic's career? Or even just within a PhD?
Some people learn fast, I guess. Yeah. Other people take time. But over a 10, 20-year period, the more abstract and disconnected with real-world things are, the more likely this used to happen. And I was wondering, why is this? Because these guys are working on some of the coolest things, in my view, at that time. And the thing I realized is the following. The more abstract, so imagine you have an idea for how to solve some global warming, let's say by moving Earth. Okay, it's a crazy, fantasy land idea, right? Now, you're looking at your friend, and he has an idea how to move a buffalo around. And you find your friend's actually way more successful in getting these buffaloes to move around than you are able to move Earth around. And in one sense, it's obvious that it's easier to move a buffalo than it is to move Earth around. But it feels unfair to the person thinking like this, that, hey, I have such awesome ideas, but I'm actually not able to do anything with this. And then I kind of solve this puzzle. And the solution is basically when you're working on more abstract, more powerful ideas, you need way more activation energy. To move Earth, you need 1 million x activation energy. Then to move a buffalo, you need 1x activation. You can just go and move it. And so when you need 1 million x activation energy to actually do something, nobody's going to award you that kind of a leverage to actually go and do it. So you have to earn it. And the only way to earn it is by compounding your activation energy. So you have to go and move a buffalo, and then you get a 10x output, and then you take the 10x, and then you go and you can now move a car, and then you take the 100x, and you can now move a building, and then you can move a city, and then maybe you can move Earth. And it's not unfair that life works like this. It's actually really, really good that life works like this. And the reason is, you give somebody who has never moved a buffalo the ability to move Earth, and then maybe the whole thing explodes. It's a very, very fragile thing to actually do that. It's very anti-fragile to give increasing compounding amounts of leverage to somebody to actually do more and more expanded scope. So now if you really had a 30-year vision that actually says, X, let's say make humans multiplanetary, to take Elon Musk's goal, you can't just go do that. You have to first build Zip2, which is just put yellow pages on the internet, which is nothing to do with make humans multiplanetary. And then you take Zip2, and then you have to build PayPal, which is let's build payment system for humanity. And then you have to go from PayPal to build Tesla and SpaceX. So this is an arc of increasing leverage to actually get to your 30-year goal. And so I would say this informs a lot of how we think about EigenLayer. You can have crazy land ideas about what you want to do, but you have to back project them into concrete things that are incentive compatible today. Otherwise, you're not going to get even a single user. And we learned this in our first startup. So we built before this called Trifecta. So, I started with coordination as the thesis for crypto. And then I was looking around blockchains have low throughput. Let's just go build a high throughput blockchain. I pitched to Ali, among other people. It's my 5th time pitching to Ali that he funded me. So don't assume that every time you pitch, you have to get it. The first time was, Trifecta. And Trifecta was this idea that, hey, let's just build a super fast blockchain. And there's 3 professors, me, my professor Pramod at Princeton, and David Shea, who's at Stanford. We were building this thing, and we just said, let's build a super fast blockchain. And this was, bad market of 2019. I didn't even know there's something called a bull market or a bear market at that time. So far out, theory land. And come in, I'm like, hey, this blockchain runs at 100,000 transactions per second. Why is nobody funding this? And what we did not realize is everything that you build has to have clear, customers from all, especially things like a blockchain actually need many different types of customers to come together, and it's extraordinarily difficult to actually orchestrate it. And so, and then that didn't go anywhere, and then we went back to academics and did a lot of work. And then after some time, I was like, okay, it didn't work because we started with just technology, not understanding the market, incentives, different participants in the market. I said, okay, let's start from market first. And we actually started an NFT marketplace. Very few people know this. We started an NFT marketplace called Artix. And this was basically I got my tenure at the University of Washington. I'm like, hey, I have to build this thing. I have this 30-year goal, but I have to get started somewhere. I was an advisor to Dapper Labs, which was building Flow and NBA Top Shot at the time. I said, okay, this is cool. There's something going on here. Let me try to build something on this. Started an NFT marketplace. I started building this stuff with the first time I'm actually touching applications, right? I was far away in infra land, building core, blockchains before that. And as I'm touching applications, I'm realizing, oh, how do you get an NFT price oracle? And I don't know. How to get a good bridge to move NFTs around? I don't know. How to do virtualization? I want to run a new execution engine on top of Ethereum. I don't know. Each one, and I look around and people are just doing band-aid solutions for each of these problems, and none of them make sense. Okay, for each of these problems, the meta problem that I was finding is, oh, you need a trust network to run a bridge. You need a trust network to run an oracle. You need a trust network to run a virtualization. And then I was then experimenting with, should I build an oracle? Should I build a bridge? And then I figured out, oh, actually, you should build the meta thing that solves all of these problems, which is build a trust network that actually solves this problem. Actually, as I was doing this NFT thing, one thing I realized is I really don't know how an NFT trader thinks. So it's very hard for me to build an NFT marketplace, which actually makes sense. Because if you don't know how your customer thinks, if you're not yourself, a customer, or if you're not very proximate to your customer, you're not going to be able to build a product that actually makes sense for them. But to build a trust network for somebody who builds an Oracle, I can immediately figure out how that works because I am the kind of person who will build an Oracle. So that actually made sense that now I can be the customer of my own product. So actually building something for that customer makes much, much more sense because the gradients that you're taking on your product are much sharper when you're the customer of your own product. So let's just go build this like meta trust network. We didn't even know how it's going to work. We called it EigenLayer already. Said anybody should be able to build arbitrary layers on top of a common trust network. So this trust network is our product. Came up with many, many iterations of it before we settled on initially restaking and later this concept called intersubjective staking or eigenstaking, which I can talk about. But the idea that you have this common trust network and anybody should be able to build services on top. So that's how we actually landed up with that.
There's an important lesson there because I feel like innovation so often happens through the exploration of something that's very specific and very concrete first. And then that leads to a set of insights that's adjacent that maybe then generalizes to something broader, where you actually realize that the specific thing you're solving is kind of very similar or has adjacencies to a much, much bigger set of problems. And that then allows you to move up the layer of abstraction and build something that is much more powerful. And that feels, especially in computing, I feel like that is like a very common pattern. And the approach of just trying to start from an ivory tower and trying to start general or start from just like big level, like high level ideas and build something that's all encompassing or extremely impactful, it's just much harder to go down that path than to kind of be grounded and connected to the real problems that are sort of more concrete in nature.
That's absolutely what we found because the previous approach was this ivory tower approach, like to build trifectas. Hey, let's just start this protocol. And this later approach was much more narrow. And when you start with something narrow, you may find something broader. And you have this view of what the long-term horizon is, but you have to take gradients from value bar.
Well, and now that you're running EigenLayer as an organization, how do you balance research, open-ended research on one hand, with product engineering, go-to-market on the other hand?
I think each of us have natural biases, and which are also natural strengths, but want to make when you're building a company, you have to make sure that you're not just building based on your natural biases. So one of the things we did when we started Trifecta was everybody who we hired and brought into the initial team were all like PhDs thinking the same way. So this was the error that we made in Trifecta. Then I realized this when starting EigenLayer, and we said, basically no researchers. So we started a company, like we are researchers, I'm a researcher myself, and some of the early founding developers were all researchers, but there's no job called researcher at Eigen Labs till very recently. So we said, because that's our failure mode. Like our failure mode would have been just go off into like crazy lands, invent new crazy stuff, but which have no tethering to reality. So we wanted to retune it, bias it in the opposite direction, which is what can we build which actually matters today. And I still always used to have this longer term thinking, but I used to basically shield the team from it because, if you just like drag everybody into like things that are long term, which don't have any material way of manifesting today, it's not useful. So we built a team which is, on this theory, which is, now common, called the zone of genius theory, which is that you want to bring different people in their zones of genius, not build a homogeneous team. Some people have this idea that like as a founder, your job is to build and scale yourself. I have an exactly opposite theory, which is that you want to find people who are in their zone of genius, potentially very distinct from your own. But the hard part when you do that is first calibrating. If I'm going to try bringing a sales or a marketing guy, how do I know what's zone of genius there? It's actually really hard. So it takes time and like sharp models to actually calibrate that. You take help of your investors, other people to actually help calibrate you there. But still, it's really important that you develop that calibration. That's number one. Number two is how do you coordinate people who are all in very different zones? you get the best guy in legal, best guy in like marketing, best guy in like, writing code. In our own team, for example, we have like crypto natives, we have like, people who are like veterans in the cloud. We have people who are successfully done like previous startups, academic researcher types. We have all of these types. And how do you build coherence into this? So those were the problems I had to solve to actually make this work.
Yeah, that's beautiful. What do you see as the end game for blockchain architectures, say 10 years from now? We could also even do the 30-year version. And then of course, like where does EigenLayer fit in that vision?
Regarding blockchain, like the first thing I heard was blockchains are truth machines. And I didn't like connect at all. Truth is a very high bar, right? Like who has access to truth? It's kind of crazy to say something's a truth machine. And so I was thinking about it, and I think the sharpest formulation I have is blockchains are commitment engines. Mm-hmm. They let you make and keep commitments. That's all. I think pretty much all what we're doing in blockchains just make and keep commitments. I started this long-term thesis with Humanity's Coordination Engine. If you think about what is coordination is communication plus commitment, right? We put 30 people together, and we should be able to communicate and work together, but we should all be able to commit to a common cause, to how we share the outputs of the work that we are engaged in, and so on. So coordination is just communication plus commitment. And internet was a communication superhighway. Mm-hmm. And crypto specifically is our commitment superhighway. So this is our specific thesis of blockchains. So if crypto is commitment superhighways, what does it mean? So when you think about commitments, you should be able to make commitments and then keep commitments. So you think of like, how do you enforce commitments as a kind of like a very fundamental question? And you think about it like, in the large arc of history, in fact, you can even say like civilization is just a system of commitments we make to each other, right? So the Constitution is a commitment, law is a commitment, like, when you marry somebody, it's a commitment, like, civilization is just a system of commitments we make to each other. Yeah. And when you think about like mechanisms for commitment enforcement, you see like, you can have an authority like a king enforce commitments. You can have a committee like the CCP enforce commitments. You can have a majority like a pure democracy, like where a majority can vote and decide what happens. That's a mechanism for enforcing commitments. But even in a pure democracy, the problem that you have is the tyranny of majority. Like a majority can dictate terms on the minority. And if you look at it, all of us are a minority in one way or the other. You can always slice and dice in a way that anybody's a minority and anybody's in the majority. So there's a tyranny of majority. And so I think of the most robust systems are self-enforcing commitment systems. Systems of commitment that don't require an authority, that don't require a committee, that don't require a majority to enforce, but they enforce themselves. That's really what crypto is, self-enforcing commitment systems. And so that's what we think about at EigenLayer is, we have this long-term view like Humanity's Coordination Engine. What we can actually like manifest is how do you maximize the volume of commitments made and kept? How do you maximize the variety of commitments made and kept? And how do you maximize the verifiability of commitments made and kept? So these are the three dimensions we think about. When you think about volume of commitments, we think of throughput, right? So when you say Humanity's Coordination Engine, how many bits of coordination can you get? Bits per second of coordination that you get. So that's our like North Star for volume. So we think of coordination engine, coordination bandwidth. What is humanity's coordination bandwidth? Actually, if you think about it, like even 30 years back, how many bits of information can humanity agree per year, right? And say, oh, this guy's the president of that country, like something like that is all you can agree. It's a few bits per year of coordination bandwidth we had as humanity.
There's also the bandwidth and I think also latency, highly limited back like 30, 50 years ago or so. Just like, for example, one very good example of this might be just like the cost of setting up a corporation and how maybe that has gotten marginally faster with some technology and with the internet and email and things like that. And you can communicate with your lawyers more efficiently. And then you still have to pay $50,000 and you set up an LLC. And then that's a structure that can enable cooperation between a group of people. But if you could actually do that with a smart contract, not only is it the number of bits, of coordination that you're able to effect through the blockchain, but it's also the fact that you can do that in a split cycle, like seconds.
In seconds and at really low cost. It's not $50,000, it's $5. I'll actually speak to the setting of the company in a bit. The volume, the rate at which you can actually communicate. So that's something that we specifically optimize. We're building a product called EigenDA, which is basically this data availability system. When you think of bandwidth, what does it mean? Like how many bytes per second of information can you write into a common ledger? That's what volume of commitments is. And so we recently did this. So EigenDA is on mainnet, and you can write data to it. So it writes data to this decentralized network and then commits these on Ethereum. And the throughput that we have today is enough to fit all blockchains. So we had this experiment called all chains run on EigenDA. So you can crawl Solana, you can crawl every chain in the world that we could get our hands on, and then you just write them in real time into EigenDA. So this is an example of taking this big picture, large, commitment systems, and then maximize volume of commitments. So it's not just volume of commitments that you are able to make, you also actually want people to be making these commitments. So that's something that we'll be working on next. So the next one is variety. EigenLayer itself is actually a mechanism for creating a variety of new commitments that you can make. What stakers are doing in EigenLayer is they're staking and then saying that, hey, I'm going to run your service correctly. Now that service itself can provide a service level commitment, which is, hey, you have this AI inference. When you call this AI inference service, you will get the right answer because of all the crypto economics underneath it. And anybody can call it permissionlessly and is censorship resistant. So you can think of each of the servers as having a service level commitment. And so variety of services can be built, on a common substrate. So you can actually get many service level commitments that can be built. Now, applications, actually, the way we think of applications is they concatenate service level commitments. So I use a DA layer to write data. I use an AI inference to kind of get verifiable inference. I use a ZK layer to get verifiable proofs. I concatenate all of these and then build an application. And the application layer commitments, what really matters to the user. If you think of all of the end user journey of crypto today, it's basically apps. I think of it as apps with commitments. That's our thesis for all of crypto, is as an end user, I'm coming in, why should I buy and hold Bitcoin? Because Bitcoin makes me two commitments that I don't get anywhere else. You own your Bitcoin. There are only 21 million Bitcoin. Just two commitments. Look at this endless number of normie podcasts on Bitcoin, right? They all talk about only these two things. You own your Bitcoin. There's 21 million Bitcoin. And these two commitments have $1 trillion of value. Isn't it crazy? So now think of each application that you're using, whether it's Facebook or Uber. If you're building a new Uber, you should be able to make a commitment that says, I can never take more than 5% take rate. This should be a perpetually enforceable commitment. It's not just that I'm taking 5% today and then tomorrow I can just rug you by taking 30% after I get all the people to come together. I should be able to make perpetual credible commitments that I, as a creator of an application, I cannot violate. And the way we think about it is each application, by concatenating a set of services that make different kinds of commitments, actually can make these commitments. Just like in the internet, you can build an application by concatenating a set of SaaS services. On EigenLayer, you should be able to concatenate a set of services, each of which make service level commitments to make app level commitments. And the way we envision it is you go to an app and then you will see these claims in English. It'll say, can't take more than 5% thing ever. You go to a Facebook, a new crypto Facebook, and then it'll say, hey, I can't change the privacy policy without a majority of users voting on it. Many, many commitments that actually matter to us as more of our life moves digital, it's absolutely imperative that we have systems like this. So that's how we view the kind of long-term thesis of coordination leading to commitments, and then we ourselves working on maximizing the volume of commitments, the variety of commitments, and the verifiability. Verifiability is can you verify these commitments on-chain? One of the things we did with Eigen, the token, is actually make any commitment that is human verifiable to transport that on-chain. Mm-hmm. So that's a whole mechanic I won't get into, but that's really how we think about it. So you want to build the maximum volume, variety, and verifiability of commitment.
Awesome. All right, well, let's open it up to questions.
So I had a question on marketing. So I think for better or worse, narratives drive crypto to a large extent, and many projects want to, set a narrative or form a narrative that other people latch onto, and very few projects actually succeed. And EigenLayer, of course, has done a very good job of getting the narrative of restaking and everything else to catch on as well. From your point of view, what has worked in terms of getting people to catch on to this narrative? And what advice would you give to any of us who are thinking of having a narrative catch on as well?
Amazing. Yeah, I think this is a really important question. So going back to my this million X activation energy problem, which is essentially the way we think about it is like you have these, this picture is x-axis is landscape of solutions and y-axis is how fit they are. When you think about it, what happens is the solution space is very non-convex, which means basically there's a lot of local maxima. And what happens is you usually get stuck, not you as in a person, as a community, we all get stuck in local maxima because there's no incentive for like moving out of the local maxima. And the only way I've figured out, the only way to move out of, or one of the big powerful ways to move out of local maxima is actually narrative and speculation. Mm-hmm. Because what speculation is basically trying to get people understand a vivid picture of the future so you can bring it forward today, and then people can impute some value into it. And then you can borrow from the future to distribute to the people who have to climb down the valley with you, right? Like this is what venture capital is, as an example, right? Speculate on, okay, this can be a big thing, and then borrow it today, and then you use that to pay your employees, and then you can move together. But you can actually do this much, much more powerfully in crypto because you can bring all the sides of your community. For example, EigenLayer is a four-sided marketplace. The first time I explained this to Chris, who later became our COO, he's like, you must be insane to try to build a four-sided marketplace. We have stakers, we have operators, we have AVS developers, and then we have AVS consumers. It's impossible, right? So you bootstrap this one side at a time. So we went stakers first, then we went operators, then we went to AVS developers. We haven't even started with consumers. So only three, that's why I say it's not yet done. It's not even started because we haven't even closed the circuit here. So that's how hard it is. Like these things take many, many years. And the longer the time scale of like actualization, the more you have to be able to bring the future to today. So yes, narrative is important. And it's not unfortunate. It's actually like fortunate that there is something called narrative to actually bring the future to the present so that you can climb out of local maxima as a society, right? Make humans multiplanetary is a narrative. And it's very powerful. It motivates people. It lets you go on the journey with Elon on this like long-term vision. Okay, so how do you do it? I think there's lots of heuristics, lots of things I had to kind of figure out. I'm so far away from this world. Like when I enter, I see I need to do it, but I'm so far away. So I have to kind of figure out all the heuristics for how to actually make this work. Never been on Twitter before, none of this stuff. So it's like a new thing. But this is one of the things I learned is when you commit to like a 30-year project, you have to do what it takes. You can't do what you're good at. You have to do what you're good at and what it takes. So, recruit people, do whatever, make it work. Okay, so how do we do it? One thing we figured out is if you have a vision, one of the best ways to like recruit more people into the vision is to find people who already think similarly, right? If coordination like acceleration is our thesis, you first find who already has that thesis. I found Ethereum already has this thesis embedded. There is like a latent collective unconscious, which is coordination is very important as part of the Ethereum psyche. So and I'm like, wow, if somebody already has that, I should not replicate their effort and go and fight with them. I should actually ride on top of it and help them achieve their own coordination goals and build on top of it. So this is very important. So first decoding the kind of so when you think about narrative is basically like belongs to the collective unconscious. Like you're speaking to what people already like want and believe in. Like otherwise you're not going to find like resonance. And usually what you want to do is you want to speak to a subset of people who are already like motivated and aligned on that direction, right? Say make humans multiplanetary, there'll be people who say like, what's wrong with Earth? You don't want those people. You only want those crazies who want to go with you to like Mars. And so that's the same thing. Like you want to speak to the people who actually like have the same belief structure. And so, but for that, you have to articulate your belief structure very clearly. So you say that, coordination, open innovation, like permissionlessness, credible neutrality, all the things that you believe in, I found like the substructure of Ethereum that actually believes in the same thing. So we can align together on that goal. And when you're aligning on a common goal, it's important to like not compete with the same people who are building the same thing. You can't align on a common goal and then just say, hey, you're doing this, I'm going to do the same thing, but a little bit different. It makes no sense. You actually figure out how to empower them to get to their goals better. So we come in, we look at Ethereum. Ethereum has the roll-up-centric era, but roll-ups are expensive. So give some ammunition, like, hey, DA, like you can actually solve it and actually get farther by having a data availability system, which is higher throughput, and so on. So make things incrementally compatible. So it's not just narrative. It's the game theory of how you structure your system needs to align with the structure of who you're trying to recruit to actually go on this journey with you. Because it's hard to find out people who will stick with you for a 30-year journey. So that's all I'll say. There's lots of heuristics that I can talk about offline.
Yeah, I would say that, I think maybe more than 50% of narrative and marketing is actually upstream. It's coming up with that crisp vision of the future that is extremely long-term, that actually stands for what you're working on, that can serve as like the thing that everyone can get aligned on. And then I think the other part is to articulate a master plan, which I think is what Elon Musk does so well. Articulate a master plan that is sort of very long-term for how you actually get there. And then more clearly you articulate both of those things, then the easier it is to actually then do the tactical sort of more blocking and tackling that actually goes into telling a story and marketing what it is that you're doing. And I think you've done a really good job at both of those things, articulating the 30-year long-term vision, but then also talking about how EigenLayer today begins to actually make progress toward that end.
I think, for example, the first thing that we did is EigenLayer was called the Ethereum Restaking Collective. It's not called the Coordination Engine for Humanity, which nobody will be like, what the hell is this guy talking about, right? It's restaking. It's one side of the four-sided marketplace because that's all that like you can actually send through the memetic sphere, restaking, just one word, right? And so after you build that, you can say, oh, AVS. AVS is a new category, and we had to work very hard to create AVS as a category. And now, like people building on Solana elsewhere, they're saying, oh, AVS. I'm very happy because, it's really hard to create categories. And then we came up with this other crazy thing called intersubjectivity. Like basically the information bandwidth that you can communicate, like it's kind of like limited to like a few bits per year. The broader that you want to reach, the fewer you have to distill the message into fewer bits.
So one thing that it seems like you're one way you're different from other founders is that I think you have a very clear and you have your vision is not the technical. So it seems like there are three levels of vision, right? There is one technical vision, restaking, and then higher level vision is you're creating a difference in developers' lives by making it easy for people to build chains. And there is an even higher beyond life vision, which is open innovation coordination engine. How do you build that muscle in your brain to think that way? I think I'm stuck at the level 2 where make ZK the substrate of computation, default substrate of computation. That seems like a level 2, but I'm struggling to get to level 3. How do you build that muscle? Are there any actionable tips you can give us to get to level 3?
That's a really great question. I think the things that I would say there is, that's why I told you the Caltech story, that question of, suppose I give you infinite time, infinite resources, infinite talent, what would you do? Is I think really, really like, it opens up like your brain to like say, what is it that you really want to like get to? So suppose you had this magic box, what would you do? So, and I think the other thing is, it goes deep into like what you believe in. Like because I'm a very like non-zero sum type thinker. If I were trying to build something which is like let's compete with somebody else, I would not be very successful at it because it doesn't fit. It's like the founder market fit. Like to build a coordination substrate, you need somebody who thinks like me because that's the nature. Like I think about everything in non-zero sum. Like I don't want to compete with anybody. If you're doing X if you're running, I'll figure out how to fly or something else. Like, I don't want to do the same thing that somebody else is. For example, when we had like restaking, we could have said, everybody thought we were going to build another liquid staking token or something like that. Said, hey, these guys already are good at it. Like, why should I do it? And we only do the things that we think nobody else is doing well. And so that's part of like our framework of thinking, and find out what is it that like motivates you, each of us uniquely, and then figure out from there, what is it that speaks to you as a person, not as a technologist? And that is what will get you at level 3.
Yeah, well, I think just from the investment side, like one kind of observation is that there are 2 approaches for coming up with a vision. And I think maybe it's a good model to think of it in 3 layers. And I think you could approach it either top down or bottom up. You could start with like a cool technology and then try to sort of extrapolate what the technology might be good for. And then sort of essentially rise to level 2 and then continue doing that to get to level 1. But then you could also start top down and think about like what is the very large problem that you want to go after and solve, and then work your way down and figure out what technologies you'd have to build to solve it. And I think the best founders do both, where you kind of have to approach the problem from both ends. You have to lock yourself in a room, think about this 30-year question with no constraints. Essentially, you have all the resources in the world, all the time in the world, all of the talent. What would you do? But then you also have to lock yourself in a room again and then do it differently. You have to then ask yourself, what are the resources that you actually do have? What is the talent that you do have access to? What are your interests? What are the things that you're uniquely well suited? And then finding kind of the intersection between those 2. And I think that the failure modes are often ones where founders approach it from only one direction. Whereas like if it's just top down, it's kind of pie in the sky, it's not grounded, it's too abstract, it doesn't land, it's very ivory tower. If it's 2 bottoms up, then maybe if there isn't like a big problem that the technology is actually ultimately going to solve, it's more just like a sort of a curiosity as opposed to something that ends up having impact. So I think maybe, I think that thinking about it in both ways and exercising that muscle. I think this question from Caltech is incredible. It's a really good question to ask oneself.
Yeah, I love what Ali said. I think it's the 2 sides. Like you have to figure out where the kind of like faraway hill is, but you have to figure out how to take gradients from here to there. I think the academic failure mode is not finding the gradient. You're just stuck in some maxima and you're just sitting there and you're wondering why the hell nobody's giving you leverage to go like move Earth. And the move the buffalo approach is, the problem is you don't know once you move the buffalo, somebody else moves the buffalo faster than you don't know what to do. So this is actually like a really important thing that I learned from the Caltech question is if somebody solves restaking, somebody solves like decentralized cloud better than me, I know what to do on top of it. That's why I say like, we welcome Ethereum to like enshrine EigenLayer. People think I'm just joking, but I'm not. If you're going to build that, because my whole goal is to build humanities coordination engine. It's not done. Unless you can run education on chain, unless you can run healthcare on chain, unless AGI is tethered on chain, we're not done. We're nowhere near done. I know what the 10 next things to do if somebody does the thing I'm doing today. And I think that is the alpha that it gives you. But if you can't do anything today with your long-term vision, then it's no good either.
One question that I wanted to ask was, first to Ali, Sreeram said he pitched you 5 times. I was so curious as to like what you saw from the investor side, Jay, with Nate. Each time he came, for those 5 times that he pitched you. So that's my question to you. And the other thing that you said, Sreeram, that I was like really surprised by was that you often shield a lot of the team from this sort of grand vision that you have. And that's surprising to me because I am perennially on crypto Twitter, and some of the messiahs that exist in crypto today that have been doing a fantastic job of evangelizing what EigenLayer can do has been the team that you've got. And so that's surprising to me. And so wondering like how you balance shielding versus what you're willing to reveal. And Ali, to you, like how do you assess that level of change? Because you've made a sizable commitment to the EigenLayer vision.
So the 4 times I pitched are first time for Trifecta, the second time seed round for EigenLayer, third time was Series A for EigenLayer, and then Series B for EigenLayer. That's 4, not 5. Maybe I'll just tell an anecdote before handing it to Ali, is the time when I pitched for seed for EigenLabs. So one of the things I decided when I built both like the NFT marketplace and EigenLabs is I'm building what I think is interesting and what I think can get customers, not what VCs want. So I have very kind of like clear thesis because there is a overfitting to VC narrative, which I think is very, very risky. So I was like, okay, and I put, and the other thing I did, which is crazy, is I put all my money in. I said, okay, nobody needs to fund this. I'm going to fund it myself because if I'm not willing to put my money in, there's no like good reason for me to go ask somebody else for their money. And so I was doing that, and I was at that time, had the idea of EigenLayer. First, we were like, virtualization was actually our first idea. You can run a different VM on a different chain. This is 2021, and we are like, okay, what VM are you going to run on what chain? Maybe you can run EVM on other chains because EVM seems to be like picking up, so why not run it on other chains? And then the chain, I looked around, and some people were trying to do it on Solana, so we are like, let's do it on Cardano. Let's build. Vanishri here is from Cardano as well, so I know her from there. Why? Because it has so much of liquidity, like $80 billion at that time, and there is no functioning smart contract systems, even today. So I was like, okay, let's go build this. And I pitched to Ali and Guy, and they were actually like, they took the call from outside, I think, the Solana conference, and they came and they're like, all this is interesting. Why the hell are you building on Cardano? But I said we don't go by VC narrative, but we take inputs very seriously. So we thought a lot about why is he saying it? Like, what does it mean that, like, why are you building on Cardano? And one of the models that I built was when you're, people say this a lot, when you're building a startup, you need to have incessant focus. And I didn't understand why people say it. And usually if I don't understand it, I don't pay much heed to it because it doesn't fit into my model. And the thing I learned about focus was, if you think of a startup is basically an exponential game. What's an exponential game? You want to translate linear amount of work into exponential impact, right? And exponential games are extremely rare, right? Who's going to take a linear amount of work and translate it into exponential output? It's like magic, right? And it's very rare. Exponential games are very rare. So if you think you have 3 ideas of exponential games, you probably have none. That's the first one. Second one is maybe you're a genius and you have 3. Then how should you allocate energy? How you should allocate energy is find the one which has the highest exponent and allocate all your energy into it. It's like, exponential is like 2 to the x, right? Like x is the energy. Then instead of having 2 to the x by 2 plus 2 to the x by 2, you should just have 2 to the x, just much bigger than 2 to the x by 2 plus 2 to the x by 2. So this insight basically explained to me why startups can absolutely not afford to be split. And initially we were split. We were saying, oh, we're going to build this on Cardano, but then we're going to also build something on Solana and something on Ethereum and this and that. And it was super clear to me, like after this pitch, came back and we were like, hey, why the hell does A16Z pass on us? And we had this meeting and we were like discussing it. And it seems like if you're building on Ethereum, they would say yes. And we don't know if that's true. I'm going to listen to Ali first time about it. But let's figure out like what it would take for us to build on Ethereum. This became a driving question for us because otherwise you're splitting the exponential. You're having a product here, a product there, and as a startup, you absolutely can't afford that. So this is one of the things I say to anybody who's building anything. People say, oh, I'm going to build on 3 restaking platforms, 4 chains. Like, get your thing together on one thing. Choose something, like whichever you think has the highest chance of success, and then like kill it before you expand it.
It's interesting to hear that from your perspective. It's really good to kind of do the retrospective. Well, I would say that now in retrospect, it's pretty clear we kind of made a mistake earlier on. We should have invested in every one of those rounds. I think that it comes back to some of what we were talking before with respect to approaching the problem from both sides. I think that we have historically had a strong bias to not invest in professors in particular, and I think that's actually probably misguided. We were too biased in that direction. I think there's some truth to the fact that there's a risk that someone who comes from academia might sort of steer towards approaching the problem top down too much, sort of thinking too well, either direction. It could be like pie in the sky, an ivory tower, or it could be it's just a cool technology, and not really being able to connect the dots between those two, which I think is what informed our bias. And I think also back in like the 2017 market, like in that cycle, in the peak of that cycle, we made many investments in professors who were building crypto networks. Professor Coins, infamously named. And I think that it is often the case that professors will ultimately not go the full length to want to build out the company and to do the hard things that a founder must do to really have impact. And they'll be too focused on just the high level ideas. And I do think that we had a blind spot as a result of that experience. I think that as it's really always great, by the way, to meet founders multiple times, because that's often the way that we invest. We'd like to have a relationship with a founder over a long period of time. So oftentimes we do pass in the initial round because that's just the initial way for us to get connected. And because we're a multi-stage fund, there are many opportunities for us to work together. And ideally, we just have like a long-standing relationship at the time that we invest, because this way there's more trust. This way we just know the person better, and it's not just about the pitch. It's more about the person, the relationship, etc. And then also, I think that gives us a view not just of the snapshot of what the progress of the company is at one moment in time, but also of the velocity, right? Like you have now you can interpolate between the various different data points that you have over time, and then extrapolate like where is that going into the future. I think one of the things that was remarkable about every time that we met Sreeram is just that the velocity, like the gradient, going from like wanting to build on Cardano to like really refining exactly what EigenLayer is, and to being very connected and grounded with not just the critical ideas that will make EigenLayer work, like the academic ideas, but also the market, kind of the surrounding players, the ecosystem, the strategy, the tactics, all of those things that ultimately will make EigenLayer successful. We really saw that evolve very, very quickly every time that we met with Sreeram. I think also at the very last meeting when we actually invested, it had become very, very clear that Sreeram is a founder, right? Like he is also a professor and academic, and he
was.
Yeah,
I left the university.
Right, exactly. But you still have like the DNA of a researcher, but you are also a founder, and you're 100% committed to making the company successful, and that became very clear, which I think was the critical thing that made us really want to work together. I think another factor, honestly, was the fact that some of the meetings that we had were purely remote. They happened via Zoom, and I've realized it's just so critical to meet people in person to really kind of, again, back to that relationship component. It's much harder to build that if it's just a remote meeting. And the final time, like I think we met in person, we had more time to really kind of get to know each other, which I think was also a very important factor.
Well, one thing I really loved about Ali and A16Z in the entire period is it's not like, hey, we've not invested in you, and therefore like we're not going to be helpful. We try to be helpful all the time, and if it works, we'll work together. Otherwise, it's okay. And I had the same attitude. Like some founders take it very personally, and they're like, oh, these guys which have passed, and I'm going to show them. So one of our my core principle is win-win or no deal. I think this is like Stephen Covey's from 7 Habits of Highly Effective People. And no deal is really, really important to make things win-win, because you work together when there is a win-win, and no deal is the default. No deal is the default. Like most times you go to pitch to a customer, you go to pitch to an investor, you go to pitch to anybody, you should expect a no deal, because alignment, think of each of you as like vectors in multiple dimensions. Alignment is rare, extraordinarily rare. So, it should not be assuming alignment. You should actually but I found A16Z to be like very, very positive sum, so it fit my personality. I've not had the same experience necessarily with other funds. So shout out to that spirit. Even the way you get the rejection is so nice. It's like, hey, A, B, C, D, E, F, G, but H, I, J, K, L, M, N, O, P. That's good.
I'm very fascinated what you said, like blockchain is a self-enforcing commitment, but democracy is a majority. But as I'm just trying to understand, like, because I think blockchain also is underlying has like a majority assumption, like it can tolerate. So I always think blockchain as like a more efficient democracy machine, while the reality democracy is like less efficient. I'm not sure if
Yeah, let me comment on this. I can talk about this for hours. Okay, so we talk about the 4 levels of commitment, enforcement, authority, committee, majority, and self-enforcing. And if you think of like before crypto, what are self-enforcing commitment systems? The biggest one is gold. So think of the problem as like value transfer. I want to send somebody value. And inside a kingdom, a king can come and say, hey, here is your ledger, here is how much you own, here is how much you own. But when you want to transact across a trust boundary, like I'm my own king and you're your king, now you want to exchange value. How do you do it? Like this is a value exchange problem in society. And the emergent solution to this was gold. And gold is self-enforcing. Once we all agree that gold is kind of valuable, now no king, no committee, no majority even can say like gold is not valuable. As long as you and I like accept to trade in gold, you can trade in gold. And it's self-verifiable. Once you get gold, you can see it's gold. It's really cool. So gold was the first self-enforcing coordination system. And after that, I think but it is only self-enforcing commitments for value transfer. Like I can send you value. In fact, in Bitcoin, you have this culture of hodl, right? You keep holding Bitcoin. I wrote this recent article called Godel. Gold has a similar long-standing culture. For example, in Indian culture, you never sell gold. It's like blasphemy to sell gold. Because people realize over generations that if you had gold, a new ruler can't come and just take it away. Like they can take your land away. But you have a piece of gold, you can just take it and run away wherever you want. You can pass it. So it's one of those very few things which is self-enforcing across long time horizons. The other one, you pointed out democracy. Pure democracy is majoritarian, right? It's dependent on the majority. The self-enforcing nature of democracy comes from the Constitution. The Constitution is self-enforcing. Constitution gives you, each individual, uniquely the right to life, liberty, property, and the pursuit of happiness. And this is like 1:1. And so the majority, like a Senate or a House voting on a bill, is still regularized by what the Constitution permits you to do. So the Constitution is the self-enforcing. Now coming to blockchains, aren't blockchains majority honest or majority coordination services? And this used to be my model, actually. We did so much of academic research on majority honest assumptions. And the day I realized that actually this is not true is back in July 2021, when I was working in practice and stumbled upon one of Vitalik's articles from 2014. People say anything you talk about today is already there in Bitcoin talk. It's kind of like that. You can find something in Ethereum research. Usually Vitalik has written something about it. So back in 2014, he had actually written about, this concept called subjectivocracy, which is essentially the idea is even if a majority of validators in a blockchain do something wrong, you don't have to accept that block because you can verify yourself that that block is wrong. So as long as you can make things self-verifiable, you will fork around majority false. So the blockchain is not correct based on a majority of nodes. That would not be a great system. And so a lot of blockchains, even major blockchains, build on this assumption that blockchains are built on majority honest trust. It's not a really good system. So Vitalik who decoded this kind of principle of forkability. Even Bitcoiners have this thing, forkability as the superpower of blockchains. And so that is the self-enforcing nature of blockchains, this forkability. Because if something's wrong, you can fork. And everybody knows what. So you fork on things which are pre-agreed and self-evident. So that's our thesis of forking. The Eigen token itself is built around leveraging the superpower of forking and then giving it to all applications. So there's a whole thing to talk about there.
Amazing. Well, thank you so much, Sreeram.
Thank you so much, Ali,
for joining us.